In this lesson, we're looking at our error in measurement. So what this is talking about is that it's an approximation of the true value, because no measurement is ever exact. If we think about a ruler, they might be slightly out, so we use these approximations at times. So there's a difference between the measurement that you take and the true value is known as the measurement error, and it can be caused by human error, so not being careful, using an inappropriate measuring device, so measuring like in centimetres instead of millimetres, so you need to make sure you're precise in those choices, and faults with the measuring devices. So all measurements should be recorded in the smallest unit of scale, and this is what is known as the precision of the device. We then talk about the absolute error, which is the greatest possible error, and it's plus or minus half of whatever the precision is. So we say half below and half above what the actual measurement was. So if we look at our example, we have a candle that was measured to be 25 centimetres long on a ruler and marked in centimetres. So what is the precision of the ruler? So it tells us it's marked in centimetres, so the precision is 1 centimetre. What is the absolute error? So our absolute error is half below this and half above this, okay? So I'm looking at the absolute error is a half times 1 centimetre, a half of that precision. So it's going to be plus or minus 0.5 centimetres, or half of a centimetre. What we then look at is being able to calculate the limits of accuracy. So you've got here the limits of accuracy are given by the upper bound, which is the measurement that was calculated, plus the absolute error, and the lower bound is the measurement that we measured minus the absolute error. So we're using this twice. So if we look at our upper bound or upper limit, it is going to be the measurement, which is 25, and we're going up, so plus 0.5. And that is going to give us 25.5 centimetres. And our lower limit or lower bound is going to be our measurement minus that absolute error, which gives us 24.5 centimetres. So you can see you've got a centimetre of variation there, because that is what the precision is. So now if we look at completing our table here. So we've got a measurement, the precision, the absolute error, and the limits of accuracy. So if I have 4.5 millilitres, so we can see here now we have a decimal, so that means that my precision is going to be one of those units, so 0.1 millilitre. My absolute error is half of that. So if you're not sure how to do the halves, type it into the calculator. But it's going to be plus or minus 0.05 millilitres. If you think of this as being 0.10, half of 10 is 5. And then we would do this so to find our limits of accuracy, we would add 0.05 to 4.5 and we would subtract it. So we get 4.45 as the lower limit to 4.55 as our upper limit. Now I've got 25 seconds, so there's no decimals, so my precision is just 1 second. My absolute error is half of 1 second and plus or minus, so 0.5 seconds. So then my limits of accuracy is going to be half our absolute error below and our absolute error above. So 24.5 seconds to 25.5 seconds. 300 kilograms. So this is going to be our precision of 1 kilogram. So my absolute error is going to be plus or minus half of a kilogram. And then my limits of accuracy is going to be 299.5 kilograms to 300.5 kilograms. And our last one's a little bit different here. We're looking at 300 kilograms again, but this time to the nearest 10. So that means my precision is to the 10 kilograms, and half of that is just going to be 5 kilograms. So I go 5 kilos less than 300, which is 295, and I go 5 kilos above, which is 305 kilograms as my limits of accuracy. So that's how we find that error in measurement and the limits. But what we can then be asked to do is find the percentage error, which is a secondary part to this piece of content. So our percentage error is of a measurement. It gives you the indication of the size of the absolute error, and it's as a percentage, hence the name. So to calculate that, we have the absolute error, which we know how to calculate, over the entire measurement, and then times by 100 to put it into our percentage. So Cameron measured his height to be 183 centimetres and the length of his driveway to be 59 metres. So we have these two measurements. We need to find the percentage error of each measurement. So if we look at Cameron's height, our absolute error is always going to be plus or minus half of the precision. So if the precision here is 1 centimetre, that is going to be 0.5 as our error over the actual measurement and times by 100. So it doesn't necessarily matter the plus or the minus here, but my error, if I type this in, is going to be 0.273%. Now we're going to do the same thing with the driveway. So the driveway is 59 metres, so I'm going to have my precision as being 1 metre, so my error is half of a metre over the original measurement times by 100. And if I type that into my calculator, I get 0.847%. Now the final question here says, which of the two measurements is more accurate? Now if we look at these, to be more accurate, it means I want less of a percentage error because that means it's closer to being the most accurate. So here, Cameron's height is the one that is closer to 0, so therefore it has the smaller percentage error. So it's smaller with percentage error. Therefore, it's more accurate.